Hi students, in this video, welcome back to the new session. In this video, we are going to discuss about reflection of light at the curved surfaces. Before start of this lesson, should have some idea about basic introduction related to light and related to reflection and loss of reflection of a light. Now, first of all, reflection of light at curved surfaces. In this, first of all, you should know what is the meaning of a light. What is light? Light is a form of energy which causes the sensation of sight or vision. What is the meaning of light? Light is a form of energy. It is a form of energy which causes the sensation of vision or sight. Sensation of vision or sight is called as a light. Okay. The study of light is called optics. The study of light is called as a optics. First of all, what is the definition of light? Light is a form of energy which causes the sensation of sight or vision. Is called as a light. The study of light is called as a optics. Understood? The study of light is called as a optics. How does this light travels? Light travels in straight lines. Okay, light travels in or light propagates in straight lines. This straight line motion of light is called as rectilinear propagation of light. The straight line motion of light is called as a rectilinear propagation of light. So, light travels in straight lines. Light can travels through all types of medium. It can propagate through all types of medium, even it can travel through vacuum. The speed of light, okay, the speed of light in vacuum is 3 into 10 to the power of 8 meter per second. The speed of light in vacuum is C is equal to 3 into 10 to the power of 8 meter per second. And if I convert into centimeter, it will become 3 into 10 to the power of 10 centimeters per second, because we know 1 meter is equal to 100 centimeters. So by using that, we can write this speed of light even in CGS system as 3 into the power of 10 centimeter per second. So the light can travel through all types of medium. Light can even propagate through vacuum. The speed of light in vacuum is 3 into the power of 8 meter per second or 3 into the power of 10 centimeter per second. Is it clear? So, sir, is the speed of light is same in all types of mediums? Okay, is it same or not, sir? Means it is not same. It depends upon the optical density of the medium. As the density of the medium is increasing, speed of the light decreases. Understood? It is the speed of light in the air is 2.999 into the power of 8 meter per second. Approximately, if you take same light travels the same speed even in air also, 3 into the power of 8 meter per second or 3 into the power of 10 centimeter per second. And the speed of light decreases in liquid medium, maybe water or some other mediums, and in solid medium it decreases further. Okay, so sir, the speed of light basically depends upon what property of the medium means optical density of the medium. That is, as the density of the medium is increasing, the speed of the light decreases. Okay, so light, first of all, the definition I told already, light is a form of energy which causes the sensation of sight or vision. I can able to see my camera, okay, and you can able to see me, okay, that is only because of mainly, first of all, reflection of light. Okay, other factors may come into action, but primarily we can able to see the objects, we can able to visualize the objects, okay, only because of a light reflection property. First point. Okay, come on. Next, after this, we'll be discussing about what is reflection. What is reflection? reflection. The process of bouncing back of light ray. The process or the property of or the property of bouncing back of light is called reflection. Understood? The process of okay, bouncing back of light, the process or the property of bouncing back of light is called as a reflection. Okay, so this reflection phenomenon is observed in case of polished surfaces, all polished surfaces, which includes mirrors and metal surfaces. Understood? So what is reflection? The process or the property of bouncing back of light is called as a reflection. All polished surfaces, which includes the mirrors and as well as the metal surfaces, okay, will exhibit the property of reflection of a light. Understood? Now mirrors, in the sense, in this all types of mirrors will come, that is plane mirrors and as well as curved or spherical mirrors. All types of mirrors comes under this. Even we have metal surfaces. For example, in your kitchen you will find many steel vessels. Example, you take spoon. We can able to see our image in the spoon. That is because of reflection property of a light exhibited by the metal surfaces. Okay, and even the mirrors, we know, we used to see our image in the mirror when you're going to party. Okay, when you are combing your hair, you used to observe your face in the mirror. How you can able to see? That is only because of a reflection of a light. Plane mirrors will exhibit the property. Curved mirrors, which includes concave and as well as a convex mirrors, will exhibit the property. Is it clear? So what is reflection? I hope you understood this. And now we'll be discussing about loss of reflection of light. Sir, what is reflection? We understood, sir. Then what is the meaning? What is the loss pertaining to this reflection of light? Okay. So majorly we'll be studying about in most of the books we'll be studying about only basically two different laws. Okay. Now I will add up one more, that is, which cannot be included completely, but you should know about it, this concept also. Loss of reflection of light. What are the loss of reflection of light? Before I start this loss of reflection of light concept, then you should know basically. Now when you see your image, whenever you see your image in a plane mirror, that is which we use in dressing table. Okay, so a mirror is a highly polished surface. Mirror has got a highly polished reflecting surface. Now if I take this one as a mirror, now one side of the mirror is coated, okay, with a silver. AG means Argentina, nothing but silver coating, metal coating. And this end is having a silver coating and this end does not have any coat. It will become a reflecting surface. It is a coated surface, coated side. It is a coated side. It is a reflecting surface, that is reflecting side. This is a plane mirror. So this plane mirror will exhibit the property of reflection. Even the curved mirrors, even I told, already given the example of polished metal surfaces. Metal surfaces also will exhibit the property of reflection. So first of all, I will explain this loss of reflection of light based on, by taking the example of a plane mirror. Okay. Now, a plane mirror has got two sides. One is called as a reflecting surface. Next one is called as a coated side. Okay. So this one is a plane mirror. Now here we are having a coated side. This is a coated surface, that is coated side, and this is a reflecting side. Understood? Reflecting surface. Okay. Now the line which is drawn, I will select a suitable point which is equidistant to both the sides, both the ends of this mirror, and I will name this point as O. Okay, a perpendicular line is drawn from point O and extended up to N. The perpendicular line, which is 90 degrees with respect to the reflecting surface, this line is named as a normal line. This is what called as a normal line. The angle of the normal line will be always 90 degrees with respect to the reflecting surface of the mirror. Okay, this is what called as a normal line. Understood? Now I am going to incident. You already studied about this basic concept in lower classes, but knowledge's sake, to make you understand the concept clearly, I am explaining even this loss of reflection of light also. Now this is a plane mirror and this is a coated surface. It is a reflecting surface, and you consider this one as plane mirror as M dash. For your understanding purpose, I am giving some names. Now listen. Now I am going to incident a light ray. For example, if I bring a laser beam, I am going to incident a laser beam onto the reflecting surface of the mirror, and is going to touch at a point O of the normal line. Okay, and after incidenting this light ray, it is going to bounce back, reflect back. For example, this is incident ray. This is incident ray. I will name it as incident ray. After incidenting this light ray onto the reflecting surface, okay, of a plane mirror at point O, it is going to bounce back, and the ray which is bouncing back, okay, is called as a reflected ray. Now the angle between incident ray and the normal is called angle of incidence. For example, I will name this one as AON. Angle AO is incident ray. Okay, AON is called as angle of incidence. The angle present between the incident ray and the normal line is called angle of incidence. For example, here angle AON. Okay, this is called angle of incidence. Okay, now after incidence, the light ray is going to reflect back. Now I will name this one as a B. Okay, and here it is BON. Okay, angle BON. This ray is called reflected ray. The angle between the incident reflected ray and the normal line is called reflected angle. Now if you measure the angle between the incident ray, normal line, incident ray normal line, and between the reflected ray and the normal line, both the angles will be equal. For example, understanding purpose, I am giving some rough angle as 45 degrees. The incident ray angle is 45 degrees. Reflected ray is angle also 45 degrees. If you measure with a protractor, the angle of incidence is equal to angle of reflection. Now, according to first law of reflection of light, the angle of incidence is always equal to angle of reflection. That is, angle I is equal to angle R. And this principle is applicable to all types of mirrors. This is a plane mirror or a curved mirror, or if you go with the polished surfaces, like some metal polished, that is a metal surfaces. Okay, so the angle of incidence is always equal to angle of reflection. It is applicable in terms of all types of mirrors. This is first law. So according to the laws of reflection of light, the first law is angle of incidence. Angle of incidence is equal to angle of reflection. This is applicable to all types of okay, polished surfaces, that is mirrors and as well as metal surfaces even. Okay, come on. Next, after that, what is the second law, sir? Now, if you observe here, the incident ray, normal line, incident ray, reflected ray, all are on the same plane. This is the same plane. Understood? Okay, this is the same plane, flat plane, plane mirror having a flat surface. The angle of incidence, angle of reflection, normal line are on the same plane. Okay, so the second law is the second law is the angle of incidence, angle of reflection and normal line will lie on the same plane. Okay, the angle of incidence, second law, angle of incidence, angle of reflection, normal line. Okay, are on the same plane. Understood? And the third one, if you consider the third one, the angle of incidence and angle of reflection will lie on either side of the normal. See, angle of incidence and angle of reflection will lie on either side of the normal. Sir, it is in which case, sir? Except when the angle of incidence and reflection is 90 degrees. Understood? For this case, it is acceptable. But if I am going to incident a light ray, for example, I will draw here, I will draw again here. Okay, this is a reflecting surface, this is a coated surface, this is a reflecting surface, it is a normal. Okay, this is a normal line. If the incident ray is along the normal, sir, if I incident a light ray along the normal, sir, this is already normal line angle is 90 degrees, we know that. Okay, so if the incident ray angle is also 90 degrees, reflected ray angle is also 90 degrees, and normal line angle is 90 degrees, we know that. So in this case, we can't write like this. Okay, so if the incident ray is along the normal, its angle is 90 degrees and the reflected angle is also 90 degrees. Understood? So these are the laws of reflection of light. Okay, this laws of reflection of light is applicable to all types of mirrors and even highly polished metal surfaces. Is it clear? Okay, I hope you understood what is light, definition of light, okay, how the light propagates. Several principles are also there, but 10th standard, not required that much explanation. Okay, so I hope you all understood this. If you like my explanation, please like, share and subscribe.